You should unmute yourself.
Yeah, I just switched over to using the Zen browser, and I don't know how to hide the sidebar. Um, does
Well,
anybody, does anybody know how to hide the sidebar? I don't really care if it's up there. It's not
we
like I
see
could do
it,
anything with it.
but oh well.
Yeah.
Yeah.
Okay. Um, hmm. There's a command for this. That that that. There we go. Okay, cool. Um, Sweet. Well, I will go ahead and get started. So can people see my slides and but not my presenter
Yep,
view?
you're good.
Okay. Cool. I can keep all my notes to myself. Well, hi, my name's Josh, and this is a talk about the unreasonable expectation of data. And Before I get started, I'll just say a little bit about myself. I'm a staff machine learning engineer at a place called Method. We're a consultancy and we do all the things that consultancies do. Um, and I'm really excited to chat with everybody here a little bit and talk about some things that I have experienced both at Method and also in previous roles that I've had working at a explainability startup and then at a certain international business machine company that maybe some of you have heard of. Um, and one thing that I have been asked to do multiple times is deal with situations where people think they have lots of data and they have unreasonable expectations about it. And the question here isn't necessarily like, what can you do with that data, but literally like, what is data? Which is kind of infuriating, but actually wound up being a pretty fun problem for me in a philosophical sense, in a, let's ponder what we just did with the last 2 or 3 weeks of our life sense, not necessarily on the like day to day, what we're doing right now. And that's because my background and my entry into doing data work and machine learning work was much more statistically oriented. And really, I got into doing all of this kind of work from a real interest in causal inference and like policy analysis and program analysis. Doing work in Africa with international development and public health groups. So I'm inclined to do philosophical questions about data. I was not prepared for where that has led me in my career. And the thing that I have heard a bunch of times in different contexts and on different projects is someone saying, we have all of these valuable insights and all of this just incredibly useful and deeply meaningful data. And when they start showing you that stuff, it's like terabytes worth of PDFs and PowerPoint files. And the disconnect between people who are data practitioners, who work in a quantitative world, and people who are not, I think, is around the nature of data itself. And that's a really interesting place to land myself, where I'm trying to figure out how to explain to people what it is, and I'm trying to figure out what to do with their expectations. So we all know, or probably we all know that in the algorithmic practice world, right, you go from some kind of well-formatted, internally consistent data that has certain characteristics throughout the data set that allow you to turn it into some kind of actionable information. Thing is, your average business person or your average analyst or your average manager level person is actually doing a different kind of thing. They're actually doing cultural practice. They're actually going from what I'm just going to call stuff into information. And that makes perfect sense if you are a human being looking at your coworker Jeff's PowerPoint presentation about what he and Sherry did while they were analyzing something and talking to clients and trying to set up a program. The process of going from this incredibly poorly structured stuff to information is something that humans do really well. And the idea of stuff itself being data is not something that I think is incredibly well understood, but it is something that I've been asked to dive into a lot. And there's this weird process where we're asking to go from stuff to data to information. And that's actually really, really different than just going from stuff to information. People have expectations when they read stuff. They look at a PowerPoint, or they look at a bunch of graphs, or they look at a PDF file or an Excel file filled with things that are encoded in colors, or information that is represented in font sizes, or things that are made meaningful by their location on the page. That's a really different um, that's a really different process than what we need to do when we want to go from stuff like totally unstructured, human readable, totally sensible stuff to a human, to turn it into data and then turn it into some form of information. And it's that process that I find really intriguing, and that I have been asked to do multiple times again, which the first time was a little bit of a shock to me, because I really thought I was going to be a machine learning engineer and, be doing like, I don't know, some kind of cool stats. And in reality, I've just been banging my head on different LLM systems a lot. And I've got some things that I've learned from doing that I think I wanted to talk a little bit about and share them, and also just open up a conversation about like what it means to go from uh, totally unstructured data into some form of actionable business insight. I've got some theories. I've got some learnings. Allow me to make some mistakes for you, so you don't necessarily need to make them. And my overall philosophical stance on all of this is that structure is, it's not all you need, but it is the bare minimum that you need. You absolutely need to create some sort of structure and give that to models that are going to take stuff and turn it into something that is usable, processable, and actionable. So there's a question out there in the world: what are LLMs actually good for? People seem to think that they can just take stuff and turn it into information. That is not true. They can take stuff, they can turn it into data, and then it can turn that into other stuff, which is by and large human readable. So the thing about this kind of like unstructured data to LLM pipeline is that you can tell any story, and that gives you a lot of rope to hang yourself with. And it gives also a lot of people completely unreasonable expectations of how data rich their documents and their document stores actually are. And it gives them unreasonable expectations about what a true pipeline and a true algorithmic approach to working with that kind of thing can do. There's a really great slide that I borrowed from someone named Jeff Eaton, where he lays out the difference between strategy and tactics and doctrine. So, how do you plan to achieve your goals? How do you implement that strategy? What are the beliefs that your strategy should entail? Here's what I see a lot. Strategy is find a bunch of meaning or find significance where no one saw any before in large patterns of data. The tactics are LLMs, right? Because they do everything. And the doctrine is LLMs are magic. That's not a good that's not a good approach to the world. It's not a good approach to getting anything meaningful out of these systems. Really, what we need to do is go from stuff to templates to maybe some kind of meaning, and the tactics that we're going to use are templates, having a rigorous taxonomy, and automating stuff. And really, my doctrine is just that LLMs are formatting engines. They're really good at that, and they're terrible at everything else. And you can use them in some ways to help you get to the formatting part, or sorry, to get to the meaning part through formatting. So the question you always have to ask is like, what could all of these things mean? And these things can be everything from terabytes of random files and notes from meetings to emails, etc. And then ask yourself, do these things actually mean that? You might think that, 10 terabytes of completely unstructured data means that you could fire all your analysts. That's not true. Unfortunately, as Q mentioned earlier in a talk, like a lot of people are drawing that conclusion, and that's a scary world to live in. I think part of our responsibility is to steer people away from that world. One thing that I have found is that you can find commonalities across things that you may not have realized that exist, and that can be really helpful. Are they meaningful? Are they important or helpful or insightful? Well, part of that is about like uh, structuring the story that you are telling with your stakeholders and the people that you're working with and the people who are actually going to be turning this stuff that your LLM spits out into some kind of information. So I like to try to think of like I am hypothesis testing based on what I think is possible to find in this data slush pile that I'm working with. And do the models and the tools that I have access to actually give me some kind of like reasonable signal out of it that I believe will plausibly be operationalizable by someone once I exit. And you have to always be very skeptical, right? Like these things are very sycophantic, as a lot of people have noticed. They're prone to hallucinating, they're prone to lying, and that does you and your client a huge disservice. So fundamentally, there is a task to turn stuff into data, and that means picking a data building task first. So filtering, labeling, classifying, clustering, ordering. Those are not things that an LLM can do. Those are not things that an agent can do. I don't care what whoever says, they will barf on it and they will screw it up in ways that will make everyone incredibly sad. The things that they can do is contextualize. So they can take actual data and put stuff around it. They can go from stuff to other kinds of stuff, or they can format things fairly nicely. Do they do this right every time? No. Are these bulletproof? Absolutely not. But I think they are potentially interesting and helpful ways to think about what people can do with their slush pile of unstructured data. And so when people say, like, oh, we'll just throw it at this model, we'll just throw it at this service, I always try to point people back to like the data building task that allows you to get from stuff to data, and then the LLM task that lets you take data and turn it into more stuff, which with human interpretation can become meaning. So a few things that I have learned. You are in fact making it up. Taxonomy is incredibly important. I actually find it more helpful to think of this as like a recommendation operation than a retrieval operation. And again, like these things need guardrails. They do not, they do not justify being given the capability of pressing an important button or executing an important trade or doing anything without some kind of human there to guarantee that they are doing the right thing. These should be low consequence tasks. They are good at that. They are good at the thing that you would have your dog do if your dog was really good at packing things into a template. In documents, the formatting of them is very important. And that's something that we as humans notice immediately. The thing in the upper right or the thing in the upper left, very important. The stuff lower down, maybe less important. Font size, font color, font choice, bold, italic, all of those things are actually like really intuitive for humans to understand. That is not so with an LLM. PDFs are really hard to work with. OCR, it's something that people seem to think is magical. It is very, very difficult to do. Describing images can be done. It's really slow, and image models are going to get the wrong thing far more often than you would like. And parsing graphs, I put really hard. The reality is, I think it's like almost impossible, which again is something that people intuitively get. So when you're trying to go from slush to data, these are all things that you will have to deal with. We always want to do any quantitative operations deterministically. Doesn't matter whether you're comparing dates. It doesn't matter whether you're doing a sum or a count. Like, do not have a large language model do that. They won't do it in a way that you're wanting them to. And then set up systems around them to have like something that verifies that your information actually exists. If you've got metadata about these files, who it came from, permissions around it, other things that it was associated with, even the folders that were in, these are all the metadata that will give you a better chance of actually extracting meaning from like unstructured data. We always want to filter everything and tag the results of those filtering operations in some way or other and log stuff as much as you can. JSON is kind of the O negative format in the language model world. JSON in, JSON out, that's less painful than other things I found. You do have to make some decisions about what noise is and get rid of it if you can. Deduplication is very important because context windows are a thing. The more stuff you pack into the context window, the worse it's going to do. If you're vectorizing things, picking how you chunk them is really surprisingly important. Like fixed size is almost always worse than context enriched in ways that are pretty surprising. And if anybody wants to chat about chunking algorithms, I'm happy to talk about that. Same goes for similarity metrics. You wind up in a vectorized space where you do some similarity stuff, and how you do that is surprisingly important. I hear a lot of people bring up graphs. You might think that you want graphs, but you probably don't want graph problems, um, unless you really, really do want graph problems, because there are situations in graphs in which graphs are extremely helpful. And in those cases, they're great, but there's not as many of them out there as many people seem to think exist. Graphs require that you do entity reconciliation. The subsidiary of a company is not the same as the company. That frequently won't be represented well in your graph. Schema reconciliation is really hard. As soon as something changes, um, as soon as the nature of an item or the nature of relationship changes, you have to cascade that all over the place. They're not fast. I see a lot of hype around different new engines as they come out, and people are hyping up how fast they are. They're always, in my experience, like in practice, much slower than any relational database if possible. And then also they're just really complicated. Graph data is really hard, and pulling data from them can be really hard as well. If possible, use one model per task, decompose them as much as possible. This is a thing that will follow instructions and spit out a lot of crap a lot of the time. So the more that you can decompose them, the easier it is to spot where stuff's going wrong. Fine tuning is fantastic. And yes, hosting fine-tuned models, especially for some of the bigger ones, it does get really expensive, but it also means that you have control over the output that you get out. If you don't want to properly fine tune, doing low rank adaptation is a really great way to constrain output. I mean, your goal is like constrain, constrain, constrain. You want to give something a template, give it a format, have it spit out stuff exactly in that format. So LoRa is a great technique for that. Deterministic finite automaton is another way to do that. You're just constraining what these models will put out, and they can become useful when you know that you have control over what comes out of them. Everybody loves talking about vibe coding. It's great, but the vibes really don't ensure that your pipeline is stable or valid. They also don't ensure that you get any meaningful inference out of them. So you might spend a lot of time chugging through somebody's data and wind up with absolutely nothing to show with it. But I do want to say that I think there's stuff to be done that can be fast and helpful and surprisingly fun. And companies spend an incredible amount of time capturing the things that happen inside of their companies or happening with their customers, and no one knows what to do with them. And I don't think that this is the, holy grail answer that a lot of people make it out to be, but I do think it's a way to recover some meaningful stuff from a lot of things that would otherwise just sit sadly and quietly on some server somewhere or in some data store and never get touched again. So I think that there are ways that this can become meaningful to people, but it has to be taken with a grain of salt, and it has to be taken as what it is, which is a data building exercise rather than just a retrieval exercise or like an insight generating exercise. Like you're really going and looking through a bunch of stuff that is not data to try to find some data in it. And with that, thank you all very much. This is my Blue Sky handle or my email or my website. Please feel free to reach out anytime. And I haven't been looking at the Discord chat, so maybe Maybe I should take a peek
Um,
and see if there's any good questions.
all right. There's been some reactions, but
Yeah.
not generally positive. I will say that. A lot of them were more like, "Oh, yeah, the thing with the L." There's a decent amount of that, which is
Yeah.
positive. I would take it. Okay, there is a question here. Do you have any good examples of where graph databases are actually a net positive? All the cases I've heard of, people had high hopes, and turns out that it was a lot of work for little to no gain.
I have never had them be useful. I like I've been in situations where we were dealing with really, really sparse data in like personalization and recommendation things. And that's not, for like a kind of e-commerce scenario, it was in a different setup. But I thought that they were going to be great because we knew, 100 things about this one kind of project and 100 things about this one kind of client. And we're like, oh, maybe we can, these things don't actually map up to one another, but maybe if we think about a graph structure, we can start getting to that. And it seemed like in this like weird, highly sparse data world, they would maybe be useful. They weren't, it was just pain. Like in little toy things that I have played with, they're really, really fun. I love the idea of like training GNNs. I've never found them to be all that helpful.
Yeah, usually it's the sparseness that gets you, right? Because it's just real
Yes.
world. It's just too many dimensions and too much nonsense out there, and you're like,
Yeah.
yeah. Okay. Any other questions you throw them in? Otherwise, I'm gonna just start like reading all these comments here. There's a lot of people who are like, at some point we were talking about when you were talking about formatting. I was talking about Excel sort by color because
Mm,
there's like some people like don't know about this, especially if they don't live in Excel like as much as some of us do, and it's
yep.
like it comes up enough that it is a literal officially implemented feature in Excel to sort by blue.
Yep.
And it's like, yeah, if you've seen those sheets where color has meaning and font has meaning, you know exactly where it's from. And then a
Yeah.
lot of people don't come from that world, and they're like, what are these people? Why would you have this feature?
Yeah, we saw a lot of stuff where data was being sorted by color in an incredibly large, how do I describe this company? This was a client that we had, an incredibly large um, governmental private equity
Mhm.
group, like I was like, wow, does your government know you do this? Like, holy buckets. Um, and yeah, it is obviously workable. I mean, when you see things that, you know, when you see weird habits, right? Like those tend to come from like very odd constraints. Like I don't think that people do things for no reason, especially if it becomes common practice. Like it's working for someone somewhere. It may not be working for you in that moment, but it doesn't mean you can throw it out. It's like the coming to a fence on a field and wondering, like, I wonder why this fence is here. Should I tear it down or not? I always try to be on the non tear it down. Also, another thing I guess that I didn't talk about a great deal is that a lot of stuff it is it is forgotten or it wasn't turned into something actionable because it's not that good. And so there's also just a, like, is this thing not helpful or is this thing not useful? Like maybe there's 100 presentations, like all the presentations that Josh made are crap, and like that's a good thing to know. If you can just say to someone, like, yeah, in the future, when you want to go peel through these things and try to find something in them, like, just skip the ones that Josh made because they're all bad.
Oh yeah,
Yeah.
that definitely happens. Where
Yep.
yeah, there's no feedback, so that thing just becomes legacy, and like, well, the previous guy did it, and and
Hmm.
it carries on until all the history is gone.
Yeah.
Ah, but yes, turning we LLMs made it so that it is possible to go mess with unstructured data in a more structured way. The fact that it made it possible did not mean it became easy or good or recommended, but now we all get to deal with that.
Yep.
Right. Um yeah, for good or for better or worse, that's the world we live in. Is that yes, I can work on we can work on PDFs now without writing code.
Mhm.
Yeah, any other questions here? Someone's typing, we'll see, but otherwise